Good morning. Welcome to another edition of Chemistry on the Fly with Mr. F. Today we're going to talk about 5.20 polyatomic ions. Now, when I say polyatomic, that's a really big word, and I often like to break it down into smaller parts. So let's do that. So poly means many or multiple. Atomic is going to mean atoms, and ions, we know ions as charged particles or charged atoms. So a polyatomic ion is going to be an ion that's made up of multiple atoms. So we're going to look back at some review stuff. So the first thing we need to review is the rule of 8. This says that atoms want a full outer ring, which is really good. So atoms larger than carbon need 8 valence electrons to fill its outer ring, and then smaller atoms, smaller than carbon, can just get away with having 2 valence electrons and their outer ring. So we're going to start off with looking at positive ions. This is a little bit of a review, and positive ions are called cations. That should be from our previous episodes. And usually we would have more protons than electrons. And cations tend to lose electrons. Not even tend, they do, they lose electrons. So let's look at a polyatomic cation. So the first one we're going to look at is ammonium ion. Now ammonium has an equation of NH4, and then the +1 is telling us that it is a cation. So the N stands for nitrogen, and it means I have 1 nitrogen, and then I have 4 hydrogens. So this is what our ammonium ion will start to look like. Now, if we look at the periodic table and find out how many valence electrons nitrogen has, it's going to have 5 because it's in group 5A. So there's our 5. And then hydrogen is in group 1A, so that's going to have only 1 valence electron, but there are 4 of them. So we're going to put them in as 4. So if I add all of those together, 5 plus 4 is going to tell me that I have 9 valence electrons, so 9V for valence electrons. All right, so let's figure out where they go. So let's put them in place. That's 4, 5, 6, 7, and 8. If we look at nitrogen, it has 8 valence electrons around it. So the nitrogen atom is happy. Well, let's look at the other ones. So the hydrogen can only have 2 valence electrons to make it happy. So let's look at all of the hydrogens. Well, they're all happy too. But what happens to this electron? There's a lone electron out here. Well, guess what? It's not needed. So it's given to something else, to someone else. So that electron is going away, and I have only 8 valence electrons. Now, one other thing that we have to pay attention to when we look at, remember this is a Lewis dot diagram, and since we took away 1 electron, I have to make it a cation, which means I put brackets around it and put the +1 next to it. Okay, now here is another polyatomic cation, and it's one of the few that there are. There are some more, but they're not very common. So this one is called the hydronium ion. And its symbol is H3O, and again it's a +1, which tells us it lost 1, or it has 1 electron that it had to give away. And this is kind of like water, but it's going to look a little different. Instead of having just H2O, it's actually going to have an extra hydrogen. And we still have the oxygen in the center. So just like the ammonium ion, we have to put a bracket around it and call it a +1. But again, this is only one of the few polyatomic cations. So the next thing we're going to look at is a review of negative ions. Now, negative ions we call those anions. Typically, they have more electrons than protons. So that's how they get their negative charge. And this is really what's important, is that anions gain electrons. So let's look at a polyatomic anion. This one's a simple one. It's a hydroxide ion. Its chemical formula is just OH, and the -1 is telling me that it's an anion. And in this case, we're going to find out a little bit later that it's actually going to gain 1 electron. So let's look at our oxygen. Okay, the O and then the H. And oxygen is in group 6A, so it's going to have 6 valence electrons. And hydrogen, since we only have one of them, it's going to have 1 for a total of 7 valence electrons. So let's place them around our Lewis dot diagram. So there's 2, 3, 4, 5, 6, only 7, but that's all that we had. And hydrogen looks like it's kind of happy. It has 2 valence electrons, but the oxygen isn't very happy. So when oxygen is not very happy, nobody's happy. So what does that mean? That this polyatomic anion is going to have to steal an electron from somewhere else. So we just did that, and now we have 8 valence electrons, and both the oxygen and the hydrogen are happy. But we still have to do one more thing. We still have to put the brackets around it and put a -1 charge. Now, when these ions get together, they actually produce ionic compounds. Shouldn't be a whole lot of surprise there, because we're going to treat them very much like the elements that we saw before with our elemental ions. So let's look at what we've talked about so far. We talked about the hydroxide ion, which is here, and we put the brackets in a -1. And we talked about the ammonium ion, and we put the brackets and we put a +1. And guess what? When these guys get together, they actually form ammonium hydroxide. Interesting. So let's look at how I would write ammonium hydroxide. So what we do with our polyatomic ions, we put them in parentheses. Now, so if I were to write ammonium hydroxide as a chemical formula, I would write parentheses NH4, close parentheses, and then open parentheses OH and close parentheses. Now, what this is telling me is that I have an ammonium ion and I have a hydroxide ion. I could certainly write this as NH5O, but we would really lose all of our identity of that this is actually an ion or an ionic compound. So one of the things that we're going to learn is that we're going to treat polyatomic ions just like elemental ions. So what do I mean by elemental ions? Well, let's look at an example. So we would have sodium hydroxide. Okay, sodium is just an element, so that would be Na, and that is a +1 ion. And if I put it with hydroxide, which is a -1 ion, I would have sodium hydroxide, and I would write it as Na, and then in parentheses, just like I did above, I would put the OH in parentheses. And let's look at another one, ammonium chloride. So I would have NH4 in parentheses, that's my ammonium ion, and then Cl, which would be my element, and that would not be in parentheses. So each of these cases, we can see that our polyatomic ions are put in parentheses when we write them in equations, or chemical equations. Now, here is a list of common polyatomic ions. Now, I'm not expecting you to memorize this list. I'm just showing you that there's a bunch of them available. These are some of the ones that we will be using, just so you can see if I say them in another video, you can understand what they mean. So the cations, there are only a couple, and I have NH4, which is my ammonium ion, and again, these are both +1 ions, and then the hydronium ion, H3O, again a +1. Now, there are several anions, and we only talked about hydroxide, but there are a bunch of them. And we have OH -1. Then we have chlorate, bromate, and nitrate. These are all -1 polyatomic anions. Now, I also have some more that are going to be -2, which, if you figured it out so far, they would be stealing 2 electrons from somewhere else. and they would be carbonate, which would be CO3 minus 2. Then I have sulfate, SO4 minus 2, and then chromate, CrO4 minus 2. And then lastly, another common polyatomic ion is going to be a phosphate, and that's going to be a phosphorus with 4 oxygens, and it's going to have a minus 3 charge. So these would be all anions. I didn't write this on here, but the cations that I show are all plus 1 charge. So one other thing that we have to pay attention to when we talk about polyatomic ions is that the charge of the polyatomic ion is carried by the whole ion itself. It's not a particular part of an atom or of the ion. So the oxygen doesn't hold on to that electron more so than anything else in any of the other things that we saw. So it's the whole ion that is charged. It's not just one atom within that ion that is charged. All right, let's do a little recap on polyatomic ions. So ions are with multiple atoms. So polyatomic ions are going to be ions with multiple atoms. There's only a few polyatomic cations. We only saw 2 of them. And there are lots of polyatomic anions. Now, I gave you a very small list. There is a huge amount of polyatomic anions available that I just didn't show. Okay, the charge is carried by the whole ion. I just showed you that in the last slide. And then when we write them in equations, we put them in parentheses. That's to tell everyone that it is going to be an polyatomic ion. And the last part, which is probably the most important, is that we're going to treat our polyatomic ions just like our elemental ions. Well, that's all we've got for today, guys. So that's chemistry on the fly with Mr. F, and as always, have a great day.